Hello, today in the lesson we will look at several examples of subtracting decimals. We know the algorithm for subtracting decimals, but I want to look at an interesting example. I need 18.467 thousandths minus 5 whole equals What do I do in this case? You and I know the rule for subtracting decimal fractional numbers. To do that, we need to write the whole part. By the whole part, point by point. But the thing is, I don't see in the number 5. What do we do in this case? The thing is that we can write any natural number as a decimal fraction. How do we do that? We say with U5, that is, it is 5 integers. So I separate the integer part with a dot. 5 point, and then after the dot I can have as many zeros as I desire and need. Let's go back to our first number. That's 18.467 thousandths. So I have 3 digits after the dot. So I need to write 3 zeros here as well. So I write 5 dots and 3 zeros. And the result is 18.467 thousandths minus 5 points. And the fractional part is 0. Well, we already know how to do it. 18.467 thousandths minus 5. And I'm writing down zeros. Subtract. 7 minus 0 is 7. 6 minus 0 equals 6. 4 minus 0 equals 4. Then we have a decimal point. 8 minus 5 equals 3. And for the next calculation, there is no value mentioned. So I'll consider it as 0. 1 minus 0 equals 1. Therefore, the final result is 13.467 thousandths. So, in this example, we turned the natural number 5 integers into a decimal fraction. To do this, we separated the whole part with a dot and then wrote down the number of zeros that we needed. So we counted the number of digits in our number and wrote down 3 zeros. And as a result, we got the correct answer. There's one more example that we're going to look at. Next, I need to subtract 1.2 tenths from 9. What are we going to do in this case? In this case, the thing is, once again, I am required to deduct a decimal from a whole number. As we mentioned previously, converting a whole number into a decimal fraction is necessary. Let's take the number 9 and document it accordingly. That's an integer fraction. After 9, we'll put a period. Then let's notice how many digits we have in the second number. It's 1 digit after the period. That's why I write 9. And 1 digit minus 1.2 tenths. See? In this case, I'm correctly writing the whole part under the whole part, the fractional part under the fractional part. Now, what I need to do to subtract. Now, I can't subtract 2 from 0, so I borrow from the whole part. This leaves not 9 whole parts, but only 8 whole parts. I'll write it down so I don't forget. So, the difference between 10 and 2 is 8. Next, and now I'm working with the whole part. Take 1 away from 8, that's 7. 7.8. When solving these examples, exercise caution. In general, keep in mind that when working with decimals, it is important to add or subtract with the same number of decimal places. To achieve this, we can use zeros to equalize the number of decimal places after the decimal point. Always remember to add the necessary digits to maintain accuracy. Another example that we're going to look at we're going to look at, it looks like 950 minus 81 whole, 351 thousandths. What is the outcome we obtained from this? Notice that we don't have the same number of decimal places. That is, here I have 3 decimal places after the dot. And at the first number I have no decimal places at all. So what do you want me to do? I have to write down 950 integers first. And after the dot, how many zeros should we put? 1, 2, 3. So I put 3 zeros, 1, 2, 3. And now I write down the number 81.351 thousandths. The whole part under the whole part. You have to write it so that the comma is below the comma. That's 81.351 thousandths. You have to do it right. I can't subtract 1 from 0. So I have to borrow from the previous digit. But in this case, I have nothing to borrow because there is also 0 here. Then I must go to the next 0. And again, I have nothing to borrow. And again. And only at the 5 can I borrow. But in this case, I have to write down that there is not a 0 left here, but a 9. And there will be a 9. And in this case, it will be 9. And only, instead of a 5, I'll write down a 4. And now we subtract. 10 minus 1 is 9. Then 9 minus 5 is 4. 9 minus 3 is 6. 9 minus 1 is 8. Again, I can't subtract 8 from 4. So I have to borrow from the 9 to do that. Here not 9 remains, but again 8. 14 minus 8 is 6. And from 8 take away 0. That's 8. The result is the following answer. 868.649. When solving such examples, be very careful. At the next lesson, we will look at some more examples. And that's all for today. Goodbye. See you again.